Okay, now let's take a look at a question where we're being asked to solve this algebraically. So this is a review of solving systems of linear equations in two variables. So you might remember that there's two methods that we can use to solve systems of linear equations. There's the substitution method and there's the elimination method. So the substitution method is where you isolate one variable in one of the equations and then substitute that equation into the other equation. So what I like to do is I like to look at the equations and figure out which equation it might be easier to get one of those variables by itself. And so I see that I have this y, right here, that negative y, and that looks pretty easy to isolate. So let's go ahead and start by, I'm going to subtract my 2x over to the other side, which will give me negative y equals negative 2x minus 5. And now we need to divide both sides by negative 1. Right, divide everything by negative 1. So that's going to give us the equation y equals 2x plus 5. And now I want to take that equation and I want to put it into my other equation in place of y. Right, so I can see this 3y here. I'm going to put that in place there. And let's go ahead and substitute that in, right? So this 2x plus 5 is going to go in here. So I have 2x plus 5. It's going to go in place of my y. Now I need to solve this for x. So I have 5x plus 6x plus 15 equals negative 7. So let's combine our x's together. We get 11x plus 15 equals negative 7. Now let's subtract our 15. The other side. So we're going to end up here with 11x equals negative 22. And if I divide both sides by 11, I'll get x equals negative 2. So I have part of my solution. Remember, a solution is made up of an x and y coordinate, right, an ordered pair. And so I found that my x was negative 2. So I'm going to go ahead and put that in there. Now I need to find my y. So I'm going to take x, which we know to be negative 2, and I'm going to put negative 2 in place of x here. Now I could put that x in either of the two equations. I'm choosing to put it here because y is already by itself, but you could put it in the other equation. And so then when I do that, I end up with y equals 2 times negative 2 plus 5, or y equals negative 4 plus 5, y equals positive 1. So now I have found the point in which these two lines are crossing at negative 2 comma 1. Now we can also solve this system of equations using the elimination method. And the elimination method is where we're going to eliminate one variable in both of the equations by making the coefficients of that variable that you're trying to eliminate opposites. So if I'm looking at my two equations, I could multiply both equations by a number to make that zero out. But right now, I only need to multiply the top equation by 3, and my y's will eliminate. So that's what I'm going to choose to do on this one. Go ahead and multiply that top equation by 3. And then I'm going to write it underneath here. So that's going to give me 6x minus 3y equals negative 15. All right, and now the elimination method is sometimes called the addition method because when we add these together, we want to have one of the variables eliminate. And now that I multiplied that equation by 3, I can see those y's eliminate, and then I'm left with 11x equals negative 22. And if I divide both sides by 11, I can see that x equals negative 2. All right, so I have part of my answer. I found my x, now I need to find my y. So again, we can just take that x, put it back in, replace x in either of the two equations. Remember, it doesn't matter which of those two equations we put it into. So let's go ahead and put it into that top equation. 2 times x minus y equals negative 5. And so we're going to put that negative 2 in place there. And then let's simplify it. See what we get. So I've got negative 4 minus y equals negative 5. Let's add the 4 over. And I get negative y equals negative 1. And if I divide both sides by negative 1, I get 1. So y equals 1. All right, and now we can see that both of these answers are the same, and they should be the same. These were the same equations, we just used a different method. All right, we'll see you next time.